Okay. So today we are going to another part to finish calculus in the about the parametric. When you say parametric, we say some equation that we have t. But today we are going to finish the calculus about it. And as we mentioned in the previous lecture, we say calculus means a derivative and integral. So we finish the derivative part. We are going to the integral part. In the integral, you can see from here, you can, if you look at the area, you say find the area. And we know when we say tangent, we say it means derivative, right? When you say velocity, in our mind, the derivative. But when we say area, we know is what? Is finding or using integral, right? Area is integral, you know, because we have, for example, if I have such a curve and I want to try to find from A to B, if I want an area of here, I say area is equal to A to B, right? And this curve, f of x, about where d of x. That's all that we have, okay? Now, if you read the question, say find the area enclosed by the figure, because the asteroid is not easy for you to sketch actually. So they give you the figure and needs the area here. And you can see the area is here, is 4 parts. All of them are equal because there are symmetry about x and y axis. And you know about that one in the as a shape and in the previous information that we have. So we can see from 0 to 1 here, from 0 to 1, we have 4 pieces, right? Instead of I say find that one, that one, that one, that one, A1, A2, A3, A4, all of them are equal. So that's why our focus, our concentration on the first quadrant, and we multiply by 4 to get the whole result, right? So the total area will be what? 4 multiply 0 to 1. So I have from 0 to 1, 4 pieces. And what? And the function is what? Y dx. This curve, which we don't know, is equal to what? About what? About dx. And you can see from here, x and y given, which both are what? Parametric. Understood? So we say by symmetry, we have 4 times, we know about that one, and t between 0 and pi over 2. Why? Because I'm going to, when I change it to the t, when I change to t, so the area from 0 to 1 to here, it will be changed from 0 as an angle to what? To tb pi over 2. Am I right? First quadrant is what? From 0 to 1 as x and y axis. How about first quadrant in the polar, or we can say in the angle measure? We know start from 0, this angle from 0 till pi over 2. How about if I talk about second quadrant? I say from pi over 2 to what? To pi, right? So that's how we deal with this situation. Now we have y and we have dx. As you know, y is given. Y is what? Sine cube, right? So I'm going to use, instead of 4, 0, 1, the area, y dx, I say is equal to what? 4 from 0 to pi over 2. Why? Because I changed the whole system to what? To t. And I know y is equal to sine cube of t, okay? And dx is what? It means a derivative of x, which it was cosine cube of t. Am I right? That's why we have d like that. And I know is equal to what? Yeah. Derivative of cosine to power 3 is equal to what? For example, if x is equal to cosine to power 3 of t, Now I am going to find dx by dt, means like that. So it will be changed to what? dt. Am I right? Multiply dx by dt. Shall I repeat that step again? Look, x as a function equal to that one. Derivative of x over t is equal to that, right? To find is equal to what? Is equal to 3 cosine t, derivative of cosine, minus sine of t, derivative of t equal to 1. This is equal to dx by dt. But I need what? I want to just dx. So that's why I say dx is equal to minus 3. We can say sine t cosine square t dt, right? We just multiply by dt. You got the idea? So I'm going to substitute that one to here. So my area will be what? From 4, 0, pi over 2. Y, it was sine cube. So sine cube of t, okay, multiply by minus 3 sine t cosine square t dt. And I know sine multiply sine will be what? Hello? And that one multiply here, it will be minus 12, 0 to pi over 4 sine to power 4 of t cosine to power 2t dt. It remains that one. And I'm waiting for what? For the result after solving the integral that we got before. And if the value is negative, you should change it to what? Positive. Why? Because area shouldn't be like that. Okay. So I'm going to say absolute value of a, that I'm going to 12 and finding the value of here. How we solve that easy integral? 8 point, I think, 3, 2, I don't know. Maybe 3, 4. We have 2 even. So how we change it? We are going to change. Sorry, this is pi over 2, not 4. Pi over 2. How we change it? Yeah. Sine will change to the square of t, okay. And that one will be square. How about cosine square will change to what? 1 plus cosine 2t over 2. And change that one to what again? 1 minus cosine 2t over 2 all square multiply 1 plus cosine 2t over t dt 12 0 pi over 2. And I'm going to leave that one because mashallah you're expert and find the integral as we mentioned before, right? So we are not going actually reviewing the integral, you know. We got one whole chapter about talking about them. Here's the idea. Here's the idea. When we say find the, where was the question? The question was about what? About finding the area. Area of what? Area of parametric equations. So how we find it? That's the idea. You got it. So how we find it? We bring it and we put the dx and dt if we have, and we do everything that we need. After solving, you'll get some things. Actually, most of the questions they are very important. They are from and dealing with the integral, of course. We are going to talk about length and the area of revolution. These two. Okay. Area of the revolution, surface revolution. These are two important things. So do not worry about the don't worry about the idea of the previous one, the asteroid one, but worry about the length and surface area or getting the area by revolution. So careful and pay attention. We have two new rules, which they are both equal. We have what? I don't know if there's a image about the idea. There's no figure. No. Okay. The rule is what? The rule is L for length, okay? And we say is equal F prime T squared G prime T squared over what? Under the square root. A and B. What's A? What's B? What do you mean by that rule? It's clear in the example. You can find it, okay? Look at here. We have what? We say L is equal to integral from A and B means that from 0 to 2 pi, 0 to pi, pi over 2. It depends on the given. So we say from 0, for example, to 2 pi, or from A to B, okay. And we say the derivative sorry, the square root of what by dt? Square root of what? Here's root, first function square, second function derivative square. So we say dx, or means that delta x square plus delta y square. You can recall as like that. So the length rule is integral from a to b generally, okay? Derivative of x by dt square plus derivative by y by dt square, all of them dt. After finishing that one, I'm going to get a length of something. For example, for example, we have what? We have a finding circumference of what? Of the circle. We need a length. So how we use that one? For example, I want to find the length of that whiteboard, the one edge of the lightboard. Okay, so that's the question, how we find it by what? By parametric equation. Now here we have a parametric. Okay, and some of the idea of the length is come from the actually Pythagorean idea. If we have something here and I want to find the length of that here, I have a starting point here and there, right? So also we have what? We have change of here, delta x, and change of y, delta y, because as a ratio, I'm going start moving from x-axis as well on y-axis. That's why you have delta x and delta y. And that one will be delta y, if you can imagine, right? Delta y. So I have delta x, delta y, and now I have a right angle, and I'm going to use what? Pythagorean, right? Pythagorean to finding c. So you say c is equal to what? C equal to delta x squared plus delta y squared and c squared. And when we want to see, we say what? That one. Understood? So the idea is come from Pythagorean actually for finding the length, even in 1 dimension, 2 dimensions, and more dimensions. So important things what? To get the idea how to solve the example. Now you got the rule, you got the idea, the background of the original things come from where, but the important thing is how to solve the example. So in the exam or quiz, you say, or your assignment, say what? Find the length of the circle. Okay, the radius is r. So generally speaking, maybe in the exam I said the radius 4. Understood? It's easy. So we have what? X is equal to what? As you know, r cosine. Y equal to what? R sine. Because I want to find this whole circle. T is from what? 0 to pi. Even the didn't mention, you can find. For example, if I say semicircle, from 0 to pi is easy. Okay. So here we are. We have x, important things, x, r cosine t, and y, r sine t. And as well, we know t is between what and what. So that's why I say length is equal from 0 to 2 pi, because I want a whole circle. Okay. Square root of delta x is equal to what? Derivative of x. Dx by dt equal to what? Minus r sine of t. But the rules say square. You remember. And how about the d of y, derivative of y? R cosine of t. But the rules say is what? Square. Now you have what? I have r square, right? I'm going to get r square sine square. Am I right, Jamaat? Oh, good. And also we have what? R square cosine square. If I bring out r square, I'll get what? As a common, of course, I'll get sine cosine. And I know sine square plus cosine square is equal to what? 1. So I got what? And later it will be what? Only r. So tell me about, did you get the idea? Shall I repeat it? It's easy. You saw that one many times, huh? During the elimination square root, huh? We have that one. But, or when we say r theta, huh? We change it to we saw many things here. So, tell me about this integral. It was not like the previous one. So it's very easy. Yeah, equal to what? R square over 2. I don't know. I'm just asking. R. So, okay, R what? Shall I leave just R? Plus C. No. Oh, plus C. Okay. What is TR plus C? Okay. R, as you mentioned, is not, mashallah. R, as mentioned, yalla. Okay. It's constant. But when you say constant, yes, it remains like a number, kick 2 out. So we have 2 to pi silent dt. So how we solve dt dx? We will get only t. But I don't say plus c. Why? Because I have, 2 pi. And we'll change to what? R t from 2 pi minus 0. And I'll get what? 2 pi r. Understood? And you know about the area and the circumference of circle, right? Area of circle is equal to what? Right? Area. Pi r square. You are right. How about circumference of area? Circumference. Two pi r. Derivative of the previous one. So now we show where the rules come from where, right? This is the circumference, Jamaat. For circle, we say circumference. For the other shape, we say what? Perimeter, right? Good, so careful. This is the circumference. That one is area. That one is chewa. That one is rubar. Okay. And I know we recorded, but just that we have something like that. Understood. So we show how to, by using perimeter, how to find the circumference of the circle and how we deal with the situation. Careful, you need to review some things here. Any question about the integral of perimeter for circle and how to use integral for finding what parametric equation? That's very important. Again, we have another equation. I'm not going to solve for you. It was the previous one. Finding area, now finding what? Finding the length, right? Length. Length is what? For example, when I say find the length of circle, what do you mean? For example, if this is my circle, I'm going to cut it here, just here, that one, by the Caesar, and I'll get what? One line, right? You know, one line. So I'll get one line. Start from here to here. Here's the line. Till here, am I right? I'm going to expand it. So the length of here is equal to 2 pi r, like that. Now in the previous example, we have asteroids. It was like that. like a star. Okay. Now I wanna what? I wanna the length of here to here to here to there. So we need a length. For example, if I have a metal and I am going to use to make that shape in the factory, so how many meters, how much we need, how much, like that. So here we are, you have x, y, so find dx squared, dy squared, put it under the square root. Mostly you'll get something like that, and here's the result. Then d of dt and find the value, it's easy. And you need 6, for example, units square or unit. So I'm going to leave that one for you. Study at home. If you face any question or difficulty, kindly bring it back to me. The second thing is what? After the length, we say what? Area. Area of surface. By what? By finding by revolution. What do you mean by revolution? What's a revolution? Sorry? No? What's a revolution meaning? First revolution? Oh, yes, revolution means that rounding, as he say Farah. How many times he did like that? So we have two. How many fans do you saw in your real life? Fan. We have the old one, and we have what? The new one, right? So that one is called about y-axis. And that one is called about x-axis, right? It's vertical and horizontal. So that's why we say we have two things here. You can see from here. We have area revolution about silent x-axis, about y-axis. So what's the difference between them? Just only we change the parameter here. Here we have x. When it's the x, we need to multiply by y. When we are on y-axis, we need to multiply by what? By x-axis. And you saw that one before, I think, right? You know, dy by dt. So we multiply just by 2 pi. So what's the difference between length and surface area by revolution? We say we have AB, okay. 2 pi depend on, for example, if here's x, 2 pi y, okay. Then what else? Then we have a length rule. dt. So just that one adds. Okay. So how's the equation? How's the question? Let me read that one. Here's the graph. You can see, we have many application here. You can see. So we have what? We say the standard parameter circle radius 1 centered at that point. Centered at that point. Kindly find on user parameter and find the area surface swept out by revolving circle. After that one, you are waiting for what? X or Y axis? We don't know. So he say about X axis. So I'm going to use that one, the first one. Understood? So the question is what? You have a parametric equation. Find the areas of the surface about which axis that he mentioned. I don't know. It mentions X or Y. I don't know. Okay, generally speaking, you can find the important things how to find the what? Derivative of here square, right? Like a previous one. So I'm going to use IC is equal to x is equal to cosine of t and y equal to what? Sine of t plus 1, I think. Yes. T between. So we have round and round. Yes, 2, 0 to 2 pi. So I say is what? First of all, I need dx by dt and square. I make it a square. So I will get what? Minus sine square is equal to sine square, right? Am I right, Jamaat? How about dy by dt? Cosine square of t. Yalla, wake up. It's time to study. Good. Yes. So now we have what? Also, we need what? Finding here. So a sine square of t plus cosine square of t equal to what? Right? So it remains what? Surface is equal to about x-axis 2 pi y Where's y? That's y. And what? Here's dt, and here's 1. You got it. So find this integral, which is very easy for you. I know, I'm sure about you can solve that one. And you get what? 2 pi. This is y. And from what? 2 pi. 2 pi is the constant. It remains the integral of sine. Yalla. Am I right? Integral of t1 from 0 to 2 pi. And you'll get the result. So it's equal to 4 pi squared. Do you have any question about it? Hello? Any idea? Any comments? No. Good.